Well, hello everyone, and welcome to another round of Let's Have a Look at Kryptonite Physics. This time they will be talking about, well, I don't know, let's see, it has something to do with to debunk the kryptonite physics, so I don't know. Let's have a look. So it is Chris, okay, so whenever I say he, it's probably justified.
This one sheet explains all you need to know to try and debunk the kryptonite physics.
Okay. I am already loving this one. There are fish. I like fish. Not as food. I don't enjoy fish as food. I like fish as animals.
At the top, for the fish bowls, A and B, it is the same experience. As bowl A.
Well, I'm experiencing the same movement. Well, movement is not a defined physical term, so this question essentially is unanswerable. If you want to know, are they experiencing the same force? Then yes, assuming that V1 is a constant, which charging that you have it in miles per hour, it most likely is. So are they experiencing the same forces? Yes. Are they experiencing the same movement? Well, A is moving. So if you have, let's say, that guy over here, for that guy, the movement is clearly not the same between those two. If by movement we say position or something, or change in position, right? So that's a bit of an unclear terminology here.
A is within an inertial reference frame. It is the same as B being on the ground. Astrophysics.
They are both in the same inertial reference frame, because inertial reference frame are characterized by the same forces applying to both, and if V1 is a constant, which apparently it is, then they are in the same inertial reference frame.
And the heliocentric model rely on this physics.
Do we?
The bottom section, we are first asking what is the difference for the B on wheel.
That's a B at 30 grams. That's a hefty B, but okay. On wheel A, B, and C. I only see A and C. Is that, or am I stupid? No, there's only A and C. Are they experiencing the same movement? Again, movement is a difficult term, but are they experiencing the same movement? Well, when it comes to forces, if V1 again is a constant, then yes, at least the B's A and C are experiencing the same forces. That is the centrifugal force arising from the rotation.
A and C.
Is A the same as B? Well, again, there is no... I'm sorry everyone, I put it in full screen mode again. I should probably figure out a better way to record my videos. What I was about to say is that there is no B apart from the B, the animal B, but there's no letter B yet, which is a bit of a confusing way to label things when you have a B and a B.
On C, it is just rotating. The B is at a constant velocity under a constant force. For the B in wheel A, we refer to known physics. Wheel rolling without slipping, or rigid body rotation with translation physics. See the video linked below.
Oh, I see what a misunderstanding is here, okay. For an outside observer, BA, the B that is right here, is of course changing in velocity all the time, because the wheel here is rolling around. Now that doesn't change the forces exerted on the B. First of all, because the forces exerted on the B, in this case, are only relevant, assuming that these are the only forces that act on the whole system, is only the rotation, and the rotation doesn't care at how fast the wheel is moving. Yeah.
The velocity of the B on A is the sum of both vectors, V1 and T1, for any point on its rotation.
If you will, velocity as seen from the outside. Okay, yeah, sure.
The B is at an ever-changing rate of velocity.
I also like how they only give the tangential velocity and not like the rotation rate.
Velocity in an ever-changing direction. A constantly changing rate of acceleration. We have now confirmed, with known physics, that the experience for the B on wheel A and C are different.
No, they are the same. I mean, experience, again, it depends. You need to use physically defined terms here, right? the acceleration that act for B on B, A, and C are going to be the same because they are rotating at the same rate, which I assume the same radius of wheel here, right? Because the formula for centrifugal force is mass times the angular velocity squared over r, I believe. R squared? I think it's r, where r is a vector. So if they move at the same rate and have the same radius, then the force is going to be the same. There's no velocity in this formula, right? No linear velocity anyway. You could substitute it with tangential velocity, but why should you, right?
If you think differently, you are denying known science.
I think you don't know known science that well. I mean, not I think, you have clearly shown right now that you don't.
We now move to the B in the carriage, on wheel B.
Ah, so there is the BB, or the BB, depending on how you want to have it. Essentially, that's might as well be the same as A. So, to answer the questions, are they experiencing the same? I'm going with force. Yes. Are they experiencing the same force? Yes. Is A the same as B? Well, that it depends what you mean by is the same. Is it the identical B? Well, probably not, unless you put it there. That's the last line here has no physical meaning.
The experience for the
But I'm confused how here he says that A is the same as B and B is the same as C. That contradicts the statement up above, right?
B is the same as on wheel A. It still has the two velocities acting on it.
Yes, and they are the same.
Putting it in a carriage changes nothing for the B.
That is true. Very well spotted here. The forces acting on BA and BB are the same.
Still rotating and moving, surrounded it with a carriage on wheels changes nothing.
That is true.
According to relative motion and inertial reference frames, the B should now have the same experience as being on C, just rotating.
And they do.
The observer's position or velocity can not change what is happening to the B.
Just correct.
You are just an observer, you don't change anything. To debunk this, you can deny relative motion and inertial reference frames has anything to do with the heliocentric model. You can deny or ignore known physics, rigid body rotation with translation, and pretend it doesn't exist. Or you
What are you on about? Seriously. The observer in the carriage will say C. He will say C to what? That you haven't asked a question yet. Very, very poor video. I mean, not quality-wise, but I mean the content. Yeah.
You can explain how
Their reality for the B in the carriage, so you might as well have said BB there. You're missing out on the good jokes. Is the same as A. Yes, it is. Nothing changed for the B. That is correct. All of the B's, A, B, and C, have the same forces acting upon them.
how magic
Assuming, again, the same rotational velocity and same tangent and same radius.
putting it in a carriage with wheels, or you standing next to it,
And assuming that V remains a constant, which it is.
changes anything. If you print this off on one sheet, you will have in your hand all the evidence you need to totally discredit relative motion and inertial reference frames.
Oh god, okay. So, by not understanding how all of this works and by using terms that aren't physical, like movement, you apparently have, quote-unquote, like in parentheses, debunked inertial reference frames, even though inertial reference frames really are a kind of a tool more than anything else. They're a tool to help think about systems, right? So that's that, and very, very funny. And if you're in linear motion, I would be interested to hear his reasoning. Imagine you can test it yourself. You could build some sort of contraption that turns your phone, right? Your phone has acceleration sensors in it. And if you can build a contraption that rotates your phone so you're in a constant way, so that your phone, like the acceleration sensors in your phone, could then measure the acceleration, right? And then you hop on a train. So one time you can do it standing still, and the next time you do it on a train that goes 100 kilometers an hour, for example, and you can still rotate the phone, and you will see that, of course, within errors, the acceleration will be the same. So I'm flabbergasted at how you could not get such a simple thing. Velocity, constant velocities do not add or change more generally change forces. And that's one of the easier things to understand about classical mechanics, and I'm afraid you haven't quite gone there. But you know what it might still be like be as in there was a pun not intended. Okay, I should probably stop now. Is there anything else, or was that it? Yes, that was it. Okay, so with that, I thank you again very much for watching. I hope you enjoyed the kryptonite physics videos, and I would ask you to maybe leave a like, or dare I even suggest you think about maybe subscribing one day. I would very much appreciate it, and well, that was that, and I'll see you in the next video. Have a nice day. Goodbye.